One of the foundational topics of linear equations are these things called intercepts. And if we take a look at a graph, let's say we have a line passing through it. Now, an intercept is where the line of a graph crosses the corresponding axis. The x-intercept is the point on the x-axis where the line crosses or touches it, so it would be right here. And likewise, the y-intercept is the point on the y-axis where the line crosses or touches it, which would be right here. Okay, so using our intuition, we can say that when a line touches the x-axis, the y value will be 0. We can see that because right here, the point where the line crosses the x-axis, it goes neither up nor down. It's right on the axis, so the y value is going to be equal to 0. And the same thing with the x value on the y-axis, on the y-intercept, because this point, the coordinate points when the point is on the y-axis, the x value is neither to the left nor right. It's just x equals 0. Now, we can use this piece of information to find very quickly the x and y intercepts of a linear equation. So let's say we have the equation y equals x plus 2. Okay, we want to know two pieces of information. We want to know the x-intercept, and we want to know the y-intercept. Okay, so to find the x-intercept, wherever the line crosses the x-axis, we want to plug in, we find it by plugging in 0 for y. We want to know what the value of x is when y equals 0. So let's go ahead and find that out. Let's plug in 0 for y and solve for x. X plus 2. So subtract both sides by minus 2. We have x equals minus 2. So the line crosses the x-axis at minus 2. So our x-intercept will be minus 2 and 0. The x-intercept is when the x value is minus 2 and the y value is 0. So to find the y-intercept, we do the exact opposite. We plug in 0 for x. We want to know the value of y when x is 0. So we can go ahead and find that. Plug in 0 for x. We have y equals 0 plus 2, or just y equals 2. And the y-intercept will be the point x equals 0 and y equals 2. So 0, 2. This is your x and y intercept. Let's do a few more of these. It's very straightforward, but we just want to get some practice in. We want to understand what an intercept is. So let's see, we have y equals 5x minus 4. And we want to know what the x-intercept is, and we want to know what the y-intercept is. So to find the x-intercept, we plug in 0 for y. So we have 0 equals 5x minus 4, and we simply solve for x, which I'm very confident we should be able to do now. Let's add 4 to both sides, so we have 5x equals 4, and divide both sides by 5 to isolate x. We have x equals 4 divided by 5. So our x-intercept is 4/5, 0. And this is our x-intercept. And we can do the same thing, the same method to find our y-intercept. We simply plug in 0 for x. So we have y equals 5 times 0 minus 4. 5 times 0 is 0. So y equals a minus 4. So our y-intercept is 0 minus 4. The first value is always x. The second is always your y value. Okay? So we're finding intercepts here. Very straightforward. We're just plugging in 0 in for the opposite variable. So if we want to find our x-intercept, we plug in 0 for y. If we want to find our y-intercept, we plug in 0 for x, and we just simply solve. Let's take a look at the next one. We have y equals minus 3x minus 4, or excuse me, minus 1. Minus 3x minus 1. Let's find our x-intercept. We do that by plugging in 0 for y. So 0 equals a minus 3x minus 1. If we add 3x to both sides, that'll make it 3x minus 1. Divide both sides by 3. We just simply have x on the left side, and we have a minus 1/3. So our x-intercept is a minus 1/3 and a 0 for the y value. Okay, we can do the same method to find the y-intercept and just plug in 0 for x. So we have y equals minus 3 times 0 minus 1. Minus 3 times 0 is 0, so y equals minus 1. So our y-intercept is 0, minus 1. Our x value is 0, y value minus 1. That's the point where the line crosses the y-intercept, or excuse me, the y-axis. It's called the y-intercept. All right, let's do a few more of these, just to be sure we get a handle on it. Let's say we have y equals 12x plus 18. Plus 18. Let's go ahead and find the x-intercept by plugging in 0 for y. So we have 0 equals 12x plus 18. We can subtract both sides by 18, which will give us 12x minus 18. Let's solve for our x by dividing both sides by 12. So we have x equals a minus 18 over 12, or just simply a minus 3 over 2, simplified by factoring out a 6 out of the top and the bottom. So our x-intercept is minus 3 halves 0. That's the coordinate point for our x-intercept. Let's find our y-intercept. How do we do that? Well, we just plug in 0 for x. We have y equals 12 times x, which is 0, plus 18. 12 times 0 is 0, so y equals just 18. And our y-intercept is 0 for x and 18 for our y value. Very simple. Let's just do a few more of these. Let's say we have y equals 6 minus x, and we want to find the intercepts. The x-intercept is found when we plug in 0 for y, so 0 equals 6 minus x. Let's go ahead and move x to the other side by adding x to both sides, which will give us a positive x equals 6. And the x-intercept will be 6, 0. Likewise for our y-intercept, we simply plug in 0 for x to find our y-intercept. So y equals 6 minus 0, or just 6. Y-intercept will be 0, 6. Okay, very straightforward finding intercepts, just by plugging in 0 in for the other value, for the other variable. Okay, let's do a couple more of these. Oh, excuse me. Let's say we have y equals minus 1/2 x, minus 1/2 x, plus 8. Okay, let's go ahead and find our x-intercept first. We do so by plugging in 0 for y, so 0 equals minus 1/2 x plus 8. We can add 1/2 x to both sides. That'll give us a 1/2 x, a positive 1/2 x on the left side, and an 8 on the other side. Always thinking ahead. I like to have my variable on the left, and I like to have it positive, and then just move everything else to the right. So we always want to think ahead when we're solving these equations. All right, and we can multiply both sides by 2 to isolate our x. So we have x equals 16. So our x-intercept will be 16, 0. Our y-intercept is found when we plug in 0 for x. So y equals minus 1/2 x, or 1/2 0, plus 8. Anything multiplied by 0 is 0, so y equals 8, and our y-intercept is 0, 8. Okay, let's go ahead and, well, I think we have time to do one more. Let's go ahead and look at this one. Let's say we have y equals minus 1 minus x over 3. Okay, start off by finding our x-intercept by plugging in 0 for y, so 0 equals minus 1 minus x over 3. Let's not get excited about x over 3. That's the same thing as 1/3 x, just with 1 in the numerator. Let's actually go ahead and move that to the other side so we can solve for a positive x. So we're adding 1/3 x to both sides. So if we separate it, we'll get 1/3 x on the left and we'll have our minus 1 on the right. And now we can simply multiply 3 to both sides, which gives us an x equals minus 3. So our x-intercept is minus 3, 0. And then our y-intercept tends to be a little more straightforward because our equation's already solved for y when it's in standard form. So y equals minus 1 minus 0 over 3. Now there's nothing special about this. This just equals 0 when 0 is in the numerator. It's only when we have 0 in the denominator that it causes a problem and we get something that's called undefined. But this is 0, so y equals just minus 1. So our y-intercept is 0 minus 1. Okay, we're out of time here. We're going to do some more of these in the next section. We're simply solving linear equations to find x-intercepts and y-intercepts. When we want to find the x-intercept, we just plug in 0 for y, and to find the y-intercept, we just plug in 0 for x, and just solve for our variable. Nothing tricky. We'll do some more of these in the next video.